joining. Had a little trouble getting from the schedule, finding the scheduled video, so just beginning new. It's 11:02 on Sunday morning, May 24th, Memorial Day weekend. This year it's Rosh Chodesh, the new month of ER, which the beginning of the third month, which if you recall is when we arrived at Mount Sinai. So I'd like to dedicate today's talk and introduction of the Moshe Emes series. We're in volume 2. Distant starlight, the age, formation, the structure of the universe, which is also known as spiral, Perlman's spiral, which stands for hyperdense protogalactic formation, preceded cosmic inflation expansion. The cosmological redshift of distant starlight attests to that hyperdense protogalactic formation preceding cosmic inflation expansion, also known as distant starlight, the age, formation, and structure of the universe, also known, aka distant starlight and Torah, which reminds me of a joke. The 3 Jewish comedians who are one, and one Jewish comedian who was 2. So 2 Jews go to the island, deserted island. It's on your SAT law exam, or law review board. And so later somebody comes to the island and they find the 2 Jews and 3 houses of worship. So how come there are 3? So, you know, the one I go to, one he goes to, and the one neither of us go to. So the 2 comedians, Jewish comedians on an island, deserted island, and they get 3 hecklers. So why 3 hecklers? One's going up, one's going down, and one's just for show. No, that's not Fiddler on the Roof. It's Jewish peer review. So no critical review. Where's the opportunity for growth? And actually, I just did the 6th chapter of Mishnah Avat, as we're in the 6th week. Today is the 45th day in the Omer. 6 weeks and 3 days into the Omer, we start the day after the first day of Yom Tov Passover, counting up to Shavuos, which now we have a fixed calendar, will always fall on the same day, but before we had the fixed calendar, we didn't know whether it would be a 29 or 30 day month of Nisan, our first month, or 29 or 30 day month of ER. It was conditioned on the testimony and declaration of the new moon. So Shavuos could have fallen on one of 2 or 3 days. But now with the fixed calendar, we always know what day it will be on. Outside of Israel, we have the extra day, a bonus day to compensate. Okay, so this, when I wrote volume 1 and the predecessor to volume 1, the recent complex creation, the volume 1 is the Moshe Emes framework for understanding science in maximum available contexts. I still wasn't sure yet of the how to align distant starlight with a universe, 6,000 rounded up, 5,780 to be more precise. See volume 3. We'll get to next week, just Torah discovery chronology. So how do we see the stars that might be up to billions of light years away if the universe is 6,000 years old? Is it time dilation, Moshe Emes, objects in Torah, or something like light in transit, variable speed of light during the creation week? So I knew there was some answer because Torah is based on my reliable teachings and life experience, is the highest level of reliable testimony, because Hashem alone has 100% perspective. So I kind of knew that there's an answer. I didn't know what it was yet until about when my mom passed on, about the time my mom passed on 7 years ago. Baruch Hashem came to me and came up with the Perlman spiral. And then thanks to some early peer review by, in particular, John Hotnet, PhD. I think he used to be associated with AIG or ICR. Gave me some early peer review, which let me know what, gave me some direction, what to focus, some of the issues I was going to have to, in astrophysics, I would have to be dealing with. And then on researchgate.net, I asked some questions, got some critical peer review. Some was respectful, some was just incredulity from arrogant, pompous people who thought they knew it all, but were projecting their ignorance and tended to project their ignorance onto others, which people who only learn one side and never think outside the box, who are arrogant, tend to do. People who are humble, true scientists will always be open-minded and respectful. They won't. They tend not to project. But unfortunately, their adherents, who don't know all the issues and haven't learned all the issues, tend to project, and therefore are the most ignorant, because they're in a box that precludes the one historic, one scientific actuality, which is a shame, but more merit for us. And more, that means more gold, more riches for us, because they're looking in a box that is empty, and we're out there picking up gold nuggets right off the ground in plain sight. Not even hidden anymore if you know where to look. And if you could ask me if you don't know. All right, well, that's why you're here today. Okay, so on the cover here is Exhibit A. It's not to scale. This represents the visible universe, and the sphere, approximate sphere of the visible universe, which we find approximates the entire universe. So just because it's a 6x9 book cover, so that's why the shape, it's not to scale, because we know it's under 4 billion light years, because there's been no ongoing cosmic expansion subsequent to the end of cosmic inflation expansion, day 4, when the universe reached mature size and density. So we're comparing now the two competing hypotheses here are spiral, Perlman spiral, and the things of creation, one of the photos we liked at the time. And it's not, even though we like spirals, my brother, used to play a lot of football. So it doesn't stand for a ordinary spiral. Even though a spiral galaxy, this would, where you see some Blueshift on the outer arms, is evidence of Perlman spiral. Okay, so only 6,000 light years rounded, 5,780 we predict. Certainly no more than 5 million light years from here to here. So if this is 4 billion, you can obviously 6,000, so it's not to scale. 6,000 light years is not the same as 4 billion light years minus 6,000 light years. So not to scale, but just giving an idea. This is what I'm going to, I for inner universe, O for outer universe, pink, because it's where the prevalent cosmological redshift of distant starlight, which is between the two hypotheses, we're going to assume that's empirical, a vast amount of empirical observations, the prevalent cosmological redshift of distant starlight, and the overall increase of that cosmological redshift with distance from us, where this is the Earth-Sun ecliptic here, with our us and the Sun and the Moon here. And then this distance, y, about 5,780 we predict, before we get to any object. Objects probably beyond that, we're seeing them when they were subjected to cosmic expansion during week 1, creation week 1. But just because they were subjected to cosmic expansion because of the light spectrum between normal, yellow, and before you get to red, if it's moving away, or before you get to blue, if it's moving toward you, there's some range from center yellow until you get to the red or blue, depending if it was moving toward us or against, or toward us or away from us. So just because that happened 6,000 years ago doesn't mean that light 6,000, 5,780, I'm going to round it 6,000, K for 1,000, 6K years ago doesn't mean that a stellar object 7,000 light years away is necessarily going to exhibit cosmological redshift. It might be 1 million light years away. It might be 6,000 light years away, or it could be, I don't know anybody who holds by more than 5 million. I think everybody agrees that certainly within 5 million, probably within 1 million, you already, you can get to an object that we see it and it has some cosmological redshift, probably not too much yet, because the further away you go, normally the more, with distance, the further away you go, the greater the amount of cosmological redshift overall. Now, in Spiral, we teach about cosmic blue shift offset, because just like the whole universe started out hyperdense, again, no dispute on the competing hypotheses here we're talking about there. You can always get somebody to dispute everything, but we're just comparing Spiral against the current consensus SCM, Standard Cosmological Model. We hope to replace and become the new, Spiral should become the new, once people study, fairly consider, and disseminate, Spiral should, hands down, it's pretty obvious once you compare them both fairly, that Spiral is a far higher, greater probability explanation of the empirical observations. So aside from the the amount of spectrum between center yellow before you get to red and visible red and visible blue, so aside from that, why it might be more than 6,000 light years to the first cosmological redshift, noticeable. We have in here, we have a hypothesis called cosmic blue shift offset, where not just the universe itself as a whole was hyperdense to begin with, but again, spiral stands for stars preceding inflation. Redshift attests to their lagging light, for short, so it's spiral. But the stars are, in the proto-galactic formation. So the stars are in galaxies. We're formed in galaxies. So look in the definition of spiral, you'll find hyperdense proto-galactic formation preceded cosmic inflation expansion. Now, if hyperdense proto-galactic formation and then during cosmic expansion, the galaxies moved apart from each other. We are, by the way, by the approximate center of not just the visible universe, but the entire universe. As we explained, the entire universe approximates the visible universe, unlike that is disputed. SCM assumes we have no favored. In fact, modern cosmology is built on that assumption, and another reason why they're not finding any gold there in a box is picked clean and void of scientific riches and advancement on a large scale. So the visible universe is only part of the maybe 10%, maybe 1% of the maybe 25%, be at the low end of estimates, but probably probably just 1/10 at best of the entire universe. SCM does not hold an eternal universe, maybe an endless loop, but they're not sure of the shape. We hold it's an approximate sphere. It approximates the sphere of the visible universe. So we do have the approximate shape of the under spiral of the universe. So I'll get back to this in a minute, cosmic blue shift offset. Now let's talk about the shape of the universe. So under spiral, we know that the visible universe approximates the entire universe. So approximate sphere, and nobody disputes, whereby the approximate center of the visible universe. Okay, that's undisputed. Okay. Again, talking about spiral against the current standard cosmological model, which is LCDM, stands for lambda comma something dark matter, DM for dark matter. Okay, so they hold, the universe is flat. So you've heard of the Earth being flat, so that's not a biblical thing. Abba kanfa ta'aretz, 4 wings. Wings are bent, even with 2 wings, you can get a fat partridge, fat chick, some kind of bird where its rings almost wrap around it, almost in a sphere. So especially with 4, one on top, one on the bottom, you could say, sphere. Abba kanfas, 4 kanfas. So that's what we call our tzitzits. Tzitzit, Abba kanfas. Those are in the 4 corners, but kanaf is a wing, kanfei hashemayim, and the 5th day Hashem made the kanfei shemayim. And Hashem's categories, like ours, bats, I think, are included in the kanfei shemayim. But 4 wings, not a flat universe unless you're don't have Torah Masara, then, and there's a loss, the generations have devolved. We benefit from cumulative knowledge, but you can only benefit with cumulative knowledge if you're building on true premise and true facts. Once you build on faulty premise, you're devolving. You're going off on a tangent further and further away from the actuality, and might zig and zag around, get a little bit closer, a little bit further, but you'll never get there until you rethink your premise, your assumption premise. So a flat universe, whether it's a saddle shape or a donut shape, balloon shape on the surface of the balloon, or whatever other shape you can come up with, it's a flat Earth on steroids. I mean, there was actually a flat disk during the original single continent. If you only include the landmass, yeah, it was a disk and a little bit of curvature prior to its limit center and high point, approximate, before the breakup of the original single continent from day 3. Here we actually have a original single continent hypothesis called draw play. You have an Earth formation hypothesis too called SNAP, draw play, SNAP, spiral, TD chronology, Torah discovery chronology, Torah discovery center, TD. So we have a lot of football analogies. Like I said, my brother Yeshua Pinchas Ben Tavi available. Like to play football, the sports. Okay, so flat on the surface universe is a far bigger mistake than flat Earth. Mistake, yes, it was. But again, you did have a flat, relatively flat disk like Frisbee, in the original single ocean. The Earth was like about 1/7 of the, or 1/5 of the surface of the Earth. So if Adam was standing on the high point, had good vision, or might be able to, before without any obstruction, or at night if there's like a contrast between dark and light, when the sun rose, sunset, maybe he could see from one end of the original single continent to the other without the need for, I'll think of that word later, how light can be bent. Okay, so let's get back to cosmic blue shift offset. Now, before the hyperdense protogalactic formation, not just the entire universe started out in a hyperdense area size, and that's, we learned that first from scripture. You can probably from Isaiah and King David, Hashem stretched out the universe. So you might be able to infer from that the universe started, since Hashem stretched it out, it was in a more compact area. Hashem stretched out like a curtain. In Spiral, we're going to learn that Hashem stretched it out, but then by the end of day 4, it reaches mature size and density. So even though Hashem, in effect, is still stretching it out, that it doesn't collapse, like there's no big crunch. Why not? Because Hashem continues to keep it stretched. It doesn't mean and that does not mean when Hashem stretch. If it doesn't say past tense, stretched, even if Hashem is stretching it, means Hashem's keeping it from collapsing back in after the end of cosmic inflation expansion day 4. I like to use a rubber band for an analogy. You stretch it out. Okay, so you can hold it there for 7,000 years or 7 minutes, and you're still stretching it out before you let go, and it collapses back into nothing. The big crunch, Hashem removes the vibrating energy that using the olive bays to keep the universe from reverting to nothing. That Hashem spoken to existence in week 1 using 10 utterances. All the matter was created on day 1. I'm not sure exactly when on day 1, probably at the beginning, but which also was the start of time, and then organized it using 10 utterances over the course of week 1. Okay, cosmic blue shift offset. Now look at the blue shifted light on the outer arms of the, would appear to be the outer arms of the, now is it all the outer arms, or could it just be the near side outer arms? If it's just the near side outer arms, you've pretty much proven beyond a reasonable doubt cosmic blue shift offset hypothesis. Because if these spiral galaxies are too far away, the near side arms, sure, have less redshift than the far side arms, but because they're so far away from us, and because cosmic redshift overall increased distance, that more than offsets the blue shift heading back toward us as each individual galaxy expanded as it moved apart from us. We also have in here, we have probably, I don't know, at least 5, haven't counted exactly, but maybe 10 hypotheses that advance the science. Many of them testable. Some of them have already, self-evident. Their predictions are testable and self-evident that those predictions are the scientific actuality. Okay. The cosmological redshift distant starlight, again, between Spiral and SCM, that's not disputed. So it's self-evident. It's cosmological redshift. We were predicted under Spiral, under SCM, we react to it. Why should have we predicted it? But yeah, we predict under Spiral, we would predict the cosmological redshift. We predict the overall increase of that cosmological redshift for distance. And we predict that there's no cosmological redshift within 5,780 light years of us at a minimum. And then because of this cosmic blue shift offset and also the spectrum between center yellow and before you get to red and blue, why it might be even further than 5,780 prayers to you actually start getting detectable redshift and detectable blue shift. Now the blue shift we'd expect, if it's due to cosmic inflation expansion that we hold, and I don't think SCM even thinks it has anything to do with cosmic expansion, because then why would it blue shift? But we show, yeah, it had to do with that cosmic expansion, because during that cosmic expansion, not only was the universe as a whole expanding, but each individual galaxy was expanding. And that's why we would predict and we find at galactic centers what appear to be black holes. But what's a black hole? Is it ongoing hyperdensity? And they used to think, oh, yeah, it's capturing light can escape it. But no. We explained the black hole fits perfectly and is actually a test too to Spiral also, because each galaxy began hyperdense, and then by the end of day 4, each galaxy was not hyperdense. So each galaxy came from its center where it started out hyperdense, and the near side moving back toward us as all the galaxies, spread out, and we have a cosmic expansion hypothesis called electromagnetic repulsion cosmic inflation hypothesis. Look in the table of contents to have the proper name of that. So they're more descriptive. So as the galaxies receded from us, the near side was moving back toward us. So if it would be the near side galactic arms, and the longer the arm, the more blue shift, the more is moving back toward us. Yes, that would explain the blue shift up to a certain, but at some point, as you get to the redshift would have overwhelmed and there would not be blue shift, but just less redshift on the near side galactic arms. And the far side galactic arms might be so redshifted that maybe they're not even visible, and maybe you can detect the radiation, but they would not be, that would accentuate the redshift on the far side of galaxies, because the light was not just a galaxy moving away from us, but the far side of the galaxy was moving away from the center of the galaxy. So it's like a compounding the cosmological redshift, as opposed to the near side would be trying, would be moving back toward us, which would be moving toward the and into the blue spectrum. That's and it seems that the spiral galaxies that are within, close but over 5,780 light years, but maybe under a million or 100 million, maybe 100 million light years, you'll see the some blue shifting on the outer reaches, and we think that might just be the near side, not the far side of the spiral galaxies. Maybe some other galaxies too. I don't know if they have to be spiral to have that effect. Okay. Oh, so aside from predicting cosmological redshift, as opposed to reacting to it, aside from predicting the overall increase in cosmological redshift with distance, as opposed to reacting to it, so I had something good, but I lost my train of thought. That'll probably come back later. Okay, we're talking about, okay, so the black, yeah, so we also predict that at galactic centers, they used to be hyperdense, no more hyperdense, and that gives the appearance, so rather than things going in toward the center, what we're seeing is a delayed reaction of things were moving away, but they did interrelate at the center. Often distant objects that are somewhat distant from each other, you can tell that they had some interaction in the past. How so, if they're so far apart? Because it used to be, the entire universe used to be more dense, and even those hyperdense protogalactic formation, so even those distant objects didn't form far apart through accretion, far apart from each other, but they formed when they were much closer and interacted. And that also helps solve the galactic rotation issue. So normally you would think after 13 billion years that, you know, these things may have, you know, spun out, lost their, you know, they spin atop, how long is it going to spin for? How many rotations are there? And if it wasn't formed early in the formation of the universe, how could we see it? You know, there's a pretty much even distribution overall of, there's some clusters, which is fine, but we see at different distances that the stars are often a like amount of galaxies throughout the, there's some dead spots, but throughout the visible universe. So if there are as many galaxies out here as there are over here, under a billion, close to the what, over 6,000, you know, well, even with it, but yeah, it's only 6,000, not to scale. There's many out here as there are over here. So these must have formed early, because now one of the foundations of spiral is a light speed limit of c. For the light to have gone from here to here, these had to form early. If they're over a billion light years away and they formed in under less than a billion years ago, the light would not have reached us yet. You know, we're seeing things in the past based on how many light years away they were when the light departed them. So certainly everybody agrees that a galaxy 5 billion, oh no, we don't agree there are any 5 billion, but we held what they think of no ongoing cosmic expansion. So, so the standard model, even if the outer reach of the visible universe, they say due to ongoing cosmic expansion since the beginning of nearly relatively soon after the beginning of time, they have 13.8 billion years, that even these most distant objects did not form. We see them, the light that departed them, when they were no more than 4 billion light years distant. I'm not even sure on the 4 billion, that might be, that's being very generous. It might be 2 billion or 1 billion, or maybe even less than that. But when the most distant stellar object. With the light departed that we're seeing here and now, it was no more than 4 billion light years distance, and that's undisputed between the two competing hypotheses. So that means anything out here up to the supposedly, under the standard model, anything up to 46.5 billion light years away, the radius of the visible universe, this is the same from here to here as it's from here to here, not to scale. We would not have a form very early in the history of the universe for us to be seeing it now. Otherwise, the light would have never reached us, especially if there's ongoing cosmic expansion, because it takes longer. So even if it departed, even if this departed from 4 billion, let's assume 4 billion and not half a billion, or not a billion, not 2 billion. We like to use 2 billion as a compromise, average, because 4 billion max, but maybe under a billion. So just say 2 billion is normally what we use for the approximate distance to the end of the universe. So if it had not, if it formed, if there was deep time and it formed only 5 billion years ago, 5 billion light years away, there's no way it would get to us, because they say ongoing cosmic expansion. So this had to be much closer, and this had to be much, much closer. In fact, they hold 4 billion light years max when the light departed it, 46.5 billion light years away now, with ongoing cosmic expansion over the past 13 billion years. So it must have formed early information of the universe, according to standard cosmological. That's 42.5 billion light years closer when the light from the furthest detectable galaxies or radiation part of the universe, 46.5 minus 4 billion minus 4 billion is 42.5 billion light years closer when that light departed. Okay, we hold the most it could be is 4 billion light years closer, minus 6. 4. So let's say that it was here. Should we do say it's here? Or all the galaxies over here, we're seeing them when they were here at this ridge and this is expanding 1 light year per year, because light travels. Again, we hold as a assumption premise light speed limit of standard light speed. Also, small c is often used to symbolize standard light speed. So spiral is premised on the light speed, and so is standard cosmological model. So again, the two, we both agree, a light speed limit of c, standard light speed. Now we find, based on that, that not only are all the vast amount of empirical observations that are the prevalent cosmological redshift of the distant starlight and that increase of overall cosmological redshift of distance, not only does that fully align with scriptural testimony, but we find it actually falsifies all deep time dependent scientific hypotheses and assumptions. So it would fall, again, based on a far higher probability science. So normally you say the stronger science is the higher probability explanation. So if the standard cosmological model has, even assuming the dark matter and dark energy required, so it's missing, but if standard cosmological model is the actuality of it has to be there, but if it's not there, that would falsify the standard cosmological model. On the rotation issue, if the missing dark matter we assume it has to be there if the standard cosmological model. We've looked, it hasn't been there neither as a dark energy, but it must be there based on our, rose-colored glasses that's the meaning, just like the black holes, hyperdensity, look at that. But no, that's just a rose-colored glasses, based on a preconceived notion. It does not have to be there. Those do not have to be hyperdense. They only have to be hyperdense if your preconceived notion of what black holes are is true. The missing dark energy galactic rotation issue, yeah, sure, it's got to be there if standard cosmological model, which is deep time dependent, as is the Copernican principle, which modern cosmology is premised on, is true. But if that premise is not true, you've constructed a box that's devoid of the one scientific, explanation that describes the one universe and all the empirical observations. So, okay, again, just if you look at the table of contents, we have the three pillars of the Big Bang, hyperdense start to the universe. Yeah, spirals checks that off. So does the standard cosmological model. A cosmic expansion. Yeah, we checked that off. We hold it was cosmic inflation expansion, which is kind of confirmed by the cosmic microwave background radiation being near black body, as close to black body as you can get, but not exactly uniform, but close enough to know that it had to be a very rapid cosmic expansion, cosmic inflation expansion being a type of cosmic expansion. Okay. Third pillar, maybe the universe had a start. Yeah, Hashem spoke and the universe had a start. There are many scientists who look at the empirical observations and agree with us, no ongoing cosmic expansion. In fact, Einstein for a while, but Einstein static. He's looking out there, there's no cosmic expansion. Now, Hubble said, oh, that cosmological redshift, look at that vast amount of cosmological redshift, the increase for distance, doesn't that prove ongoing? I think that means ongoing cosmic expansion. Einstein capitulated. We call that his biggest blunder. He thought his biggest blunder was thinking Einstein static. When he capitulated, we call that premature capitulation. If he would have stuck around and held on till he thought of spiral, he would say, hey, that prevalent cosmological redshift, it aligns with spiral and the increase with that redshift. The distance overall aligns with spiral a lot better than it does with Hubble's explanation of it. So yeah, maybe back to Einstein static. We also had a scientist in our Torah Discovery think tank group, and he had his PhD, David Patovi, in steady state oscillation. So we said, well, steady state oscillation. So he thought, universe has come big bang, big crunch, many times, but not based on a Torah perspective. But based on a science perspective, he sees steady state oscillation. So, but you can't get something from nothing unless you have. But we can't, and science can't. But Hashem did, and during week one, at the beginning of week one. So that's actually proof. Any God that's physical, like the flying spaghetti monster, fights against the laws of science, whereas Torah, Moshe had it right to begin with. Hashem is not physical. Otherwise, where did Hashem come from? Hashem is eternal because Hashem preceded time. If you preceded time, you're eternal because you're there, and we assume that. And kind of once Hashem is gone, you have one way to tell Hashem's gone is there'll be nobody to tell if time is gone because everything will collapse back to nothing unless you're a non-physical. Maybe our souls can I would think our souls might, if Hashem preserves them and doesn't snuff them out, our souls can live from now to eternity, from ever our souls were created. Maybe they were created before time, just waiting to be distributed to their physical bodies. So anyway, Hashem preceded time. Hashem, if something happened to Hashem, and Hashem was no more, then the physical universe would revert to nothing. So as long as there's something, you know Hashem's still here holding things together. Okay, so Einstein's biggest blunder was premature capitulation to Hubble. There are many scientists who, I don't know how many, but a lot, that look at the observations and say, hey, you know, we don't see any cosmic expansion. And we teach, no, there was cosmic expansion, but it ended by the universe at mature size and density by the end of day 4. Okay, we only have 12 minutes left, and I've only covered a small fraction of the work. So anybody want to make any, people want to email in the comments and I can respond to them directly. Next week, we're going to be getting to Torah discovery chronology to show the alignment of Torah testimony and ancient civilization. Okay, so I'm just going to peek in here and try to take a few excerpts from this. So in the abbreviations, we define spiral and some of the other things. If you didn't catch all the terms, just look in to the, you can use a free look inside on Amazon. And we also have on academia, we have posted an introduction that shows the comparison between the two competing hypotheses, spiral and the standard cosmological model. Okay, so you start, okay, so we show in Exhibit A, we're here, normal light, any object within 5,780, for sure getting their normal light, was never subjugated to cosmic expansion. We show any point in the universe within 5,780 light years of that, they are also getting normal light from any object within 5,780 light years of them, any point you are in the universe. So you show that in Exhibits B, C, D. Here's a parallax. We should explain parallax. Just count the cosmic distance ladder. Here's a nice. I also want to thank my brother-in-law for helping me with the graphics. His name is on the graphic, George Rosinas. And yeah, the other participants, families and friends, my wife, of course, instrumental in my being able to have the success. Look at this. This shows that, pretend this was the parallax during the cosmic expansion. You know, we went from hyperdense and protogalactic formation preceded cosmic inflation expansion. So during a hyperdense phase, the angle here, and with parallax, so it would appear the same as here, and a little bit later when we weren't so dense, and then at the mature size and density. So the angle here is the same as the angle here, same as the angle here. This is the same as this. So just because we see that angle does not mean that we're seeing it for light that departed here. The light could have departed here when it was, the universe was not at mature size and density, and we're only seeing about a tiny fraction of the universe when it wasn't mature size and density. Any light that we see that has been that was ever subjected to cosmic expansion happened when the universe was denser during cosmic inflation, before the end of cosmic inflation expansion, day 4. Okay, we told you about draw play, about the formation of the original single continent, snap hypotheses, how the formation of the heavy elements, when that happened at a hyperdense, and how the Earth, where the cause and effective processes, heat, time, and pressure. We didn't get to radiometric dating last week, but did in the prior introduction to the Moshe Emes series. But Izzy Osher used to be an active participant, Veterans Day. He was in the Pacific Theater, Army Corps of Engineers, like my grandfather was in the Army Corps of Engineers before Izzy, toward World War I. So Charles Vogel, bless him. So heat, time, and pressure in rock formation, we apply that to stellar formation. So we have that HTP, heat, time, pressure, stellar formation hypothesis, and we have MVP, my mom's kind of her initials, Miriam Vogel, not her middle name, she didn't have a middle name, Perlman, MVP. We have the most valuable view, most preferred view, but anagram, Miriam Perlman, most preferred, V for view. In the entire universe, most places in the universe you can only see, except probably only about 6,000 light years out, rounded, 5,780. And then you have to see the other exhibits B, C, and D. We show what the view is, whereas we can see almost the entire visible universe, almost any distant place in the universe they can only see a tiny fraction of what we can see in the universe. So, the Copernican principle is horrible. For anybody who wants to understand what they're looking at in astronomy, you better get spiral. Okay, distant Starlight and Torah so you can know what you're looking at. Okay, and appreciate it more. Okay, so all right, so we're 5 minutes left. Okay, so we have HTP, galactic, stellar and galactic formation, 3 pillars of the Big Bang. So you could say a Big Bang. Okay, steady state oscillation. So steady state oscillation. So you start down here, you go. Oh no, take it again, start again. Okay, here. Okay, go like that. And getting smaller and smaller. So here, where you're coming back, so right here, we could be on the first crest. This could have been day 1. By the end of day 4, here you go up on the first crest, first plateau, before I start heading down and going like that. So we're right on steady state oscillation. If you don't want to call it Einstein static, call it steady state oscillation on the first crest. Okay. We have Perlman versus Hubble. We have some graphs to show the math, some equations. We have some equations. We try to use basic equations and basic science. It's really not rocket science. But it is, somebody else can get into the exact, exactly how much cosmological redshift at what distance. We know it overall, just like, okay, so the pi, right? So you could go, how many digits do you need to go really for it to be practical? In the Talmud, they rounded it down to 3. If you go to, a fraction, to the 2nd, 3rd, 4th, 5th, by the time you get to the 10th decimal point, you could already have the circumference of the universe pretty almost exact. So we give we give the basic math. You don't have to, if you want to get really detailed and precise, you can, but we do more than enough to understand the science. Okay. Okay, so we get several examples here about Hubble versus spiral. How spiral, Perlman spiral, is higher probability and better explanation of the empirical observations. We talk about Olber's paradox. Spiral has a far better resolution to that than the standard cosmological model has. Cosmic microwave background radiation aligns better with spiral than it does with the standard cosmological model. Don't forget, we do stop hyperdense, we do have cosmic inflation, just like the standard cosmological model. Axis of evil, we've got axis of good, axis of truth, because it confirms we are by the approximate center. We do have a favored place in the universe. Okay. Here's the matchup. I have this free in academia and a little bit older draft on researchfaith.net. So follow me on YouTube. Please subscribe, like, share. We're on LinkedIn, Quora. Follow me on Quora. If you can't find me on my page, Torah and Science on Quora, Facebook, Twitter. Okay, so hope you hope I covered, gave a little tease, gave a little taste of what distant starlight and the age formation structure of the universe. I'm confident that we've advanced the science, far more than anybody who's still going by the standard cosmological model can ever do when it comes to astrophysics and cosmology and the age formation structure of the universe. And again, I had the big advantage of a Torah education, Torah testimony education, which gives the context, which I explained last week, the recent complex creation framework for understanding science in maximum available context. Science, if it's based on true premise, can also help us understand Torah in context. But that's only if the science is true. So everything in Torah taking context is true. Their hypotheses come and go. Some will stand the test of time. We'll find out if it stands the test of time. And as I predict, will become within a few decades, hopefully sooner, the new standard in the new standard cosmological model. Okay. Email. Actually, don't comment. Put in your comments. Try to answer, or at least point in the right direction. There are several problems with the standard cosmological model, and spiral solves probably all of them. All those questions are answered if we have the use spiral instead of the standard cosmological model and the faulty deep time dependent premise. Have a good week. Happy Rosh Chodesh. Happy Shavuos. The 50th day from the second day from the maybe the first day of Passover, 7 complete weeks to the 50th day. We'll have Shavuos. Moses goes up. So next week, hopefully, we'll be doing some Torah discovery chronology and the alignment of ancient civilization. Sign in then, or just watch after. It'll be up on YouTube. Thank you. Okay, watch as just because this does not, if this screen goes black, it does not mean the big crunch happened already. Okay. See if that worked. End stream. Are you sure? Okay.